All right, welcome to day 13 of DC-CAS test prep. What does that mean, Mr. Kent?
We got 3 weeks left.
3 weeks, that's it. And then we got the big dance. Just like we have March Madness now, we're going to have April Madness. And today we're going to deal with graphical representations of data. Mr. Kent, do you know anything about graphical representations of data?
I know a little bit. I used to be a researcher, so we dealt with numbers all the time, got comfortable with numbers, talked all about different ways to display it. And today we're going to be looking at 5 different ways to display some numbers.
Great. Mr. Kent, you want to talk us through the first one a little bit?
So for the first one, looks like we're looking at this chart here. It says solo news conferences through the first 3 years in office. Okay, then I got a bunch of names here, and then got some bars with numbers on it. So the first step you always want to do when you're looking at data with numbers at all is you just want to take a second, chill out, read the chart, and see what's going on. Okay, looks like I got 21 for Ronald Reagan, 72 for George H.W. Bush, and so on. So once you kind of get a feeling, so I'm looking at presidents and the number of news conferences they have, then I'm going to go over to the question, which is right over here. And the question asks, which president conducted the least number of solo news conferences in his first 3 years? So just as Mr. Atherton, the least is our key term here. So the least means the fewest amount. So if I go back over here, this bar, no, looks like we have 11 has the smallest bar. So George H.W. Bush has the least number of news conferences, which looks like 11. So I would say George W. Bush is my answer for the first one. Mr. Atherton, are you going to take it away on the second?
Awesome, yep. So that was our bar graph. So the type of graph is a bar graph. Our next one is something else you've seen before, which is a pie chart, or a pie graph, a circle chart. You're going to see many names. But it's that one with the big circle. And so the next type is a circle graph, or a pie chart. I'm going to put the 2 names that you might see on the DC-CAS. All right, let's go back to the pie chart. Now let's talk about, like Mr. Kent said, what is it asking, or what is it doing, what's it showing us, what kind of data is it showing? Do parents have the right to monitor their kids' smartphone use? That's a question near and dear to your heart. All right, so let's take a look at it. Well, it's a pie, 360 total degrees, it's a big circle, and 89% said yes, parents do have the right to monitor their kids' smartphone use, so it's the biggest part of the pie. 89% of the pie is devoted to the yes column. And now we also have the little sliver that says no. 6% of the total amount of people that were surveyed said no. So it's a smaller part of the pie, 6% of the pie. And also, we have a little category that says not sure. So that says 5%, it's smaller than the 6% piece of the pie. And so we have 3 pieces making up the entire pie.
And what do they add up to, Mr. Atherton?
They all add up to 100%. Pie charts add up to 100%, 360 degrees, an entire circle. And so you're going to get a question like this. If 400 people were surveyed, how many said yes? So let's go back to the chart and take a deep breath and calm down. Well, they give us percents. They don't give us numbers. Let's calculate the numbers. So if we want to find out who said yes, 89% of them did. So I'm going to write 89% of 400. All right? We got to turn that into a number. So let's take this percentage and turn it into a decimal by doing what? Going left 2 spaces. So 0.89. And now of 400, of means to multiply. So let's multiply that times 400. And I have a calculator, like you have at your table, and I'm going to type in 0.89 times 400. That equals 356 people. So out of the 400 people, 356 of the people said yes. They are part of the 89% of the pie. So that's our next one, a circle graph or a pie chart. Mr. Kent, what's our next one?
Our next one, if we look at here, looks like we got a line moving around. So this is going to be a line graph, okay, or a line chart. So our term is a line graph, okay? And so just like we talked about before, let's look, and we first want to understand what we're graphing. So here we got Super Bowl ad costs, and it says the price for a 30-second spot in millions of dollars.
Woo! Millions.
So on my y-axis, which is the vertical axis, looks like I have dollar amounts, and then on my x-axis I got 2003, then a bunch of blank spaces all the way up to 2012. So those must be years, okay? So I got years on my X, dollars on my Y. So if I go over to my question, which is, in the year 2009, how much did a 30-second Super Bowl ad cost? Well, I can go back to my graph, and the first thing I got to do is I got to find 2009. All right, 2009 I think is closer to 2012 than 2003, so I'm going to count backwards. So this, if this is 2012, this has got to be 2011, 2010, 2009. Okay, so at this point is 2009, and if I go up, I get where my line graph is, and if I go over, boom, it looks like it cost $3 million. So my answer is, remember my units, $3 million.
That's a lot of money. A lot of money for a news ad, or for a Super Bowl ad. So I'm going to erase this so we can move down a little bit. And we have two more quick ones to do, which we'll make happen. Alright, the next type is called a stem and leaf plot. You're going to see these on the DC-CAS. So let's label this stem and leaf plot. Alright? And this one gives us a title as well. Always look at the title of your graph. It says, this stem and leaf plot lists the ages of the U.S. presidents at the time of their inauguration. Inauguration just means when they become president, when they get into office. And so we have a stem, which signifies a certain place value, and we have a leaf, which signifies a certain place value. And in this case, they give us a little code down here. 5, that big bar, 0 equals 50 years. That means the stem is the tens place, and the leaf is the ones place. So tens and ones. And so it's very easy to read. So let's look at the question. What was the age of the youngest president at the time of their inauguration? Well, we look at the first row. The stem is 4, so the tens place is 40. And the leaf is 2, 3, 6, 6, 7, 8, 9, 9. That means presidents were 42, 43, 46, 46, 47, 48, 49, 49 years old at the time of their inauguration. So the youngest age is clearly 42. So the youngest is 42 years. Don't forget your units. And it also asks the oldest. So let's go down to the bottom where 6 is our tens place, so we're in the 60s. And so we have 60, 61, 61, 61, 62, 64, 64, 66, 68, 69. All of those ages. So the oldest one would be 69. 69 years old for the oldest. And don't forget your units. 69 years old. Alright, and the last one, Mr. Kent?
Last one, alright, so our last one is what we call a scatter plot, okay? So a scatter plot always compares two different variables, okay? So that's, all of these other ones we're only looking at one variable. Here we have two different variables, and so here we have a year and a participant. And I actually want to correct myself, a line graph compares time to one variable here. But here we're also looking at time, it looks like on the x-axis, and then number of participants on the y-axis. Always take a look at your title to figure out what the graph is telling you. It's a snowboarding competition. So these must be, in different years, the number of people who participated in a snowboarding competition. Maybe Maurice was one of them, because I know he was in the Chill Club. So, first things first, understand your graph, then we move on over to our question. What is the difference in the number of participants between 2003 and 2005? So keywords here are difference and then between these two numbers. So I got to look at the number of people who placed in 2003, which is right here. If I go across, it looks like it's right about maybe 31. It's just a little bit above. And in 2005, if I go up on 2005 and I go straight across, this looks a little bit higher. So maybe this is 52, okay? So if I'm looking at the difference, I'm looking at the distance between 31 and 52. How many more did they score, did they participate in 2005 versus 2003? So to find the difference, just take the difference between the two. So in 2005, there were 52 participants. In 2003, there were 31. 52 minus 31, you got it, is 21 participants.
Good units. I like the units. And so Mr. Kent and I just talked a lot of stuff revolving around just thinking and reasoning. Sometimes there's no great one way to do things. It's all up to you to decipher what's going on in these data charts and these graphs. So it's all up to you. You can do it. Real quick, I just want to show you one website that's very cool if you like some of these displays. We have the USA Today. Let me go to the quick thing. USA Today has a ton of these charts for sports, money, news, life. Look at all these they got. USAtoday.com. Check it out on your own time. If you're over at Khan Academy, feel free to do so. Go Blue. We'll make things happen.
Go Blue.